Uh, Welcome to Electrical Machine 1 lecture, and this is lecture number 27 or 28. In the previous lecture, uh, auto transformer was discussed, and one numerical also discussed. Now today we will discuss one more numerical based on auto transformer. So a 25 kV 2000 by 200 volt two winding transformer is to be used as a auto transformer with constant source voltage of 2000 volt at full load. Unity power factor, calculate output of transformer and power conducted by auto transformer. So it is a 25 kV kVA 2000 by 200 volt two winding transformer. Now this two winding transformer is converted into the auto transformer, whereas the source voltage is 2000 volt. Okay, so this is converted into the auto transformer. So first step is to calculate. Okay, now it become an auto transformer where source is 2000 volt. Okay, it means that source is 2000 volt. Say this is the winding is connected in series. So it is connected to 2000 volt. Whereas one winding is 200, this winding is 200. So it become a step up transformer. Okay. So this voltage will be, since it is a similar polarities are there, so it is 2200 volt. 2200 volt. Suppose this is converted into the auto transformer. Now we will start the calculation. First, it is a two winding transformer. So two winding transformer where the primary voltage is 2000 volt and secondary voltage is 200 volt. So this is 2000 volt, 200 volt. So it is a IH and this is say IL, high voltage winding current and low voltage winding current. Okay. So under such condition, IH is equal to 25 into 10 raised to 3 divided by 2000 equals to 12.5 ampere. Whereas low voltage winding current is 25 into 10 raised to 3 divided by 200 volt equals to 125 ampere. So this is the current delivered current in the HV winding and LV winding under full load condition or as per the rated value of transformer. Okay. Now we will convert into the two winding transformer in the auto transformer. So this is the this two winding transformer is connected in series in such a way that it become a two winding, it become a auto transformer. So this is 200 volt. V1 is equal to number of turns is N1 total. Okay. This is the secondary winding, sorry, load connected. And this is A, B, C. This is 200 and 2200 volt. Number of turns is N2. Here a number of turns is N2. Now this current is I2. This current is I1. Okay. So here it is it will be the secondary voltage. The load is connected to the high voltage winding. So definitely it is I2, I1 minus I2, I1 minus I2, and it is I2, this is I1. So under such condition, this is say the current delivered by LV winding is 125 ampere. Current to this LV winding is 125. Whereas the current in this winding, that is HV winding, is equal to 12.5 ampere. Okay, and they are opposite. So total current will be 137.5 ampere. Okay, this is the total circuit parameter of auto transformer. Now KVA rating of auto transformer. KVA rating of auto transformer is equal to V1 I1, which is equal to 2000 multiplied by 137.5 ampere equals to 275 kVA. So auto transformer rating, KVA rating is greater than two winding transformer. This is one way to calculate. Or it may be calculated as the KVA rating of auto transformer KVA rating of auto transformer equals to, what is that? VAB into IAB plus VBC into IAB, which is equal to VAB. A to B is 200 volt multiplied by current is 125 ampere. B to C voltage is 2000 volt multiplied by current 12.5 ampere. IAB is 125 ampere. IAB is equal to 125 ampere. And hence it is equal to 200 multiplied by 125. It is a 25 kV plus it is equal to 250 kV. 250 is equal to 275 kV. Okay, so the answer is same. This answer and this answer is same. Either KVA can be calculated from the input or output current and voltage, or it is by this relation. So from this one, KVA transform, KVA transform is equal to 25 kV and kVA conduct is equal to kVA of auto transformer minus kVA transform. Okay, kVA transform. So it is equal to kVA of auto transformer is 275 minus 25 is equal to 250 kVA. So this is the kVA conduct. Now, as suppose it is a on given power factor, so only just multiplying the power factor, we'll get the kilowatt output or kilowatt conduct or kilowatt transformed by the transformer, isn't it? Now, can we calculate the volume of copper required, uh, volume of copper for auto transformer is equal to 1 minus ratio. Definitely the ratio is N1 upon N2 or N2 upon N1, which is smaller for the calculating the copper saving in auto transformer. So here it is 220, 200 N1 upon N2 or V1 upon V2 is 2200 multiplied by volume of copper for two winding transformer. So it is equal to 2000 divided by 2200. It's a 0.9. So 1 minus 0.9 into volume of copper for two winding. It means that it is a 0.1 time or 10% of copper required as compared to the volume copper required for the two winding transformer. So what is the saving? So it is 0.1 multiplied by volume of Cu for two winding. It means that let the 100 kg copper required for two winding transformer, then the copper required for auto transformer is 0.1 multiplied by that value is say 100 grams is needed for auto transformer. So what is the saving? Saving is 90%. Hence, the saving of copper, therefore, saving of copper is equal to 90%. Okay. So there is in this way, we can calculate the saving of copper. Let the at power factor is 0.8 and full load efficiency of two winding transformer is 95%. We will consider here let let power factor is equal to 0.8 lag, and full load efficiency is equal to 95% for two winding transformer. So determine efficiency of auto transformer. Okay. So under such condition, the losses in transformer, therefore, losses in two winding transformer is equal to, it is quite simple, it is 1 upon efficiency minus 1 into kilowatt. Okay, so kilowatt is nothing but the kVA multiplied by power factor. So it is 1 upon efficiency is 0.95 minus 1 multiplied by kVA. So 25 multiplied by 0.8, isn't it? Since kilowatt is equal to kVA into power factor, simply. So hence the power losses is equal to 1052.6 kilowatt, isn't it? It is in watt, sorry, not kilowatt, it is in watt. Since the transformer losses, since the transformer is working at full load condition in auto transformer, the losses will remain same. So therefore, efficiency, since, okay, we'll write since auto transformer at full load, therefore losses equal to 1052.6 watt. It is the iron plus copper losses, isn't it? Total losses. So under such condition, the efficiency of auto transformer equals to kVA, write the kVA of transformer, kVA auto transformer multiplied by power factor multiplied by 10 raised to 3. Okay, since losses is given in wattage, kVA auto transformer multiplied by power factor multiplied by 10 raised to 3 plus losses, which is equal to it is 275 multiplied by 10 raised to 3 multiplied by power factor is 0.8 divided by 275 multiplied by 10 raised to 3 multiplied by 0.8 plus 1052.6 into 100. So efficiency is 99.5%. So see here, if a two winding transformer is converted into the auto transformer, kVA rating is get increases. So first point is increase in kVA rating. Second, copper saving, and third is increase in efficiency. This is the some advantage of auto transformer. Even though this is the advantages of auto transformer, but there are some major limitation. One is the problem of isolation. We never use auto transformer as a distribution transformer. Okay, take one more example. Say a 10 kVA, 1150 volt by 115 volt two winding transformer has full load efficiency is 96% at 0.6 power factor. The transformer is used as 1150 by 1265 volt auto transformer. Okay, so there are different parameters to be determined. First, we'll write the what is the data. A 10 kVA, 1150 by 125 volt two winding transformer. Two winding transformer has full load efficiency is equal to 96% and power factor is equal to 0.6. Okay, the transformer is converted into two winding transformer is converted to auto transformer as 1150 oblique 1265 volt. It means that the primary voltage V1 is 115 volt and secondary V2 is 1265 volt. Means it is a step up transformer. So okay, so we'll start solving. First we will draw the Equi diagram. So this is the auto transformer. This is V1 and secondary voltage V2 is equal to 1265 volt and V1 is equal to 1150 volt. It means that they are connected in series and polarity is same. Okay. Now, what is the HV current and what is the LV current? So, as a two winding transformer, HV current is equal to 10 into 10 raised to 3 divided by 1150 volt is equal to. So 1150 volt, it is 8.69 ampere. And similarly, low voltage winding current 10 into 10 raised to 3 divided by 125 equals to 86.95 ampere. Okay. So under such condition, this is the I2, current is I2, this current is I1 and it is I1 minus I2. Okay, so I2 is, it is the HV current, so it is 8.69 ampere. Okay, it is the current is equal to how much? It is HV current is okay, sorry, this is This is HV winding and this is LV winding. Okay, this is 125. So this current will be, do not confuse. This HV and LV current is from the two winding transformer. This is from two winding transformer. So HV current means the current in the HV winding 1150 volt. Okay, so it is equal to the 8.6 ampere. So it is 8.69 ampere, whereas this current I2 is the current in the LV winding 125 is 86.95 ampere. So the addition of these two will be the total current. It is 95.65 ampere. Okay, this is the entire circuit. It is A, B, and this is C. Now, we want to calculate the kVA rating of auto transformer. So kVA rating of auto transformer, it is equal to, either we can calculate from V1 I1 or it is V2 I2, isn't it? So earlier case we have calculated the current from input side. Okay, we will calculate from, say it is a V2 I2, which is equal to, the voltage is 1265 multiplied by current 86 point, it is going to calculate from 126, it is 86.95. This is 86.95 ampere. Therefore, the kVA rating is 109.999. Say it is 110 kVA. This is the kVA rating of auto transformer. First parameter, it is the auto transformer kVA rating. Okay. Now, second is estimate the power transformed in kilowatt by auto transformer at full load unity power factor. Okay. Next parameter is found. This is one assignment questions from NPTEL course. So the estimate power transfer. So power transferred, power transformed in kilowatt at unity power factor. So it is quite simple at unity power factor. Therefore, kilowatt is equal to kVA of auto transformer multiplied by power factor, which is equal to 110. 110 multiplied by 1. So it is simply, it is 110 kilowatt. So power transferred is 110 kilowatt. Next question is estimate the power conduct in kilowatt by the auto transformer at full load unity power factor. So power conduct is the first, what we'll do, power conduct. Okay, next parameter is needed is power conduct. Power conduct at full load unity power factor. So power conduct is equal to, power conduct is equal to, by two way, it is the kVA of auto transformer minus kVA transformer. So kVA transformer is at 10 kV, isn't it? So 110 minus 10 is equal to 100 kVA, isn't it? It is in kVA, power conduct. So multiplied by, okay, so this is the kVA. First we will calculate the kVA conduct. kVA conduct. Okay, so under such condition, or you may calculate, this is from kVA conduct. kVA conduct is equal to VBC multiplied by IAB. So see in the circuit diagram, VBC voltage, VBC, B to C is 1150 and current is IBC is equal to 86.95. So 110, 150 multiplied by 80 is equal to 86.95. So again, it will be 100 kVA. So kVA conduct is 100 kVA. Therefore, kilowatt conduct is equal to 100 multiplied by 1 is equal to 100 kilowatt. So this is the next parameter as per the question. Okay. So these are the third one. Next is to estimate the efficiency of auto transformer at full load, unity power at 0.6 power factor. Okay. So what would be the calculation? The same which just we have done. So losses in transformer, losses in two-winding transformer. Okay, what we want to calculate? Efficiency of auto transformer. Next parameter is asked. So losses is equal to 1 minus efficiency, 1 upon efficiency minus 1 into kilowatt of auto transformer. So 1 upon efficiency, what is the efficiency is given? 0.96%, 0.96 minus 1. Output of, it is in kilowatt of the transformer, it's a 10 kVA multiplied by 10 raised to 3. It is VA multiplied by power factor is 0.6. It is from the two-winding transformer. Okay, this calculation from two-winding. This is important. So what is the total losses in two-winding transformer is 250 watt. 250 watt. Now efficiency of auto transformer is equal to kVA auto transformer divided by into 10 raised to 3 multiplied by power factor as it is. So kVA of auto transformer multiplied by 10 raised to 3 multiplied by power factor plus total losses. So it is 110 multiplied by 10 raised to 3 multiplied by 0.6 is the power factor, and 110 multiplied by 10 raised to 3 multiplied by 0.6 plus 250 watt, and hence the efficiency is 99.62%. So these are the calculation based on given data. Okay. Now, one more question is again from NPTEL assignment. So the question is like that. A circuit is given. The circuit, three-winding auto transformer is loaded as shown in figure, and all loads have unity power factor. So the circuit diagram is given here. The circuit diagram is like that. 3 winding instead of 2 winding, it's a 3 windings. This is the circuit shown as this circuit is shown in the question itself. This is 525 kVA load. It is up to this point, it is 250 volt. A, B, this point is C, and this point is D. Voltage is connected is 1500 volt up to this one, and up to this one more load is connected, and the voltage is 500 volt. This is 500 volt. This voltage is not given, and here it is a 90 kV. 90 kV. This is given. Now estimate the current in ampere in section AB. What is the need? Current IAB is equal to how much? Enter the positive value. Okay, means the current direction may be different, but you have to write the answer in only the magnitude. Second question is estimate the current in section IBC. IBC and current in CD. These 3 questions, these 3 currents has been asked. Okay. So what would be the procedure? Voltage across load. Therefore, we'll try to solve this one. Voltage across load. Say this is across load 25 kVA. What would be the total voltage? This voltage is 1500 up to this one and 25. So 1500 plus 250 is equal to 1750 volt. Okay, so it means that this much voltage. So this is the numerical. It is given in the black color is all the given data. I am writing by the different color. So the voltage is 1750 volt. Okay. Yes. Now the current in this section. The current in this section will be say the total current is this current is I2. Okay. This current is say I1. Okay. So what would be this current? This current will be I1 minus I2. Okay. And this current will be I1 minus I2 minus I3. So this is the one. And the current here, it is I3. Black color diagram and figure is the question data, and whereas different color is we are going to giving some nomenclature as well as some of the calculated value. Okay, so now load current. Therefore, load current means this load current. Load current is equal to 525 kVA, 10⁻³ divided by 1750. It is equal to 300 ampere. Okay, so which current is 300 ampere? The current which is flowing in the load is 300 ampere. So this is 300 ampere. So which is in section A to B. Therefore, current in section IAB is equal to 300 ampere. So one data is over. Okay. So this is equal to 300 ampere. Now, can we calculate I3? Yes, we can calculate I3. I3 is equal to, it is kVA, it is in 90 kVA, load is 10 raised to 3 divided by 500 equals to 180 ampere. So this current is equal to 180 ampere. Okay. We know the I2, we know it is necessary to calculate current I1. So how we are going to calculate the current I1? Any clue? Okay, we can calculate the current if we are able to calculate the total load supplied by auto transformer, or yes, total load supplied by the auto transformer either in kilowatt or in the V. Okay, so now from this figure, V1 I1 is equal to V1 I1 is equal to V2 I2 plus V3 I3. Since the load is connected, on these two windings. Okay, so if we are able to calculate the total VA, so total VA is equal to 1750. Current already calculated 300 ampere plus V3 is 500 multiplied by current is 180 ampere, and total VA input is, we can calculate either or, we can calculate the current I is equal to 1750 multiplied by 300 plus 500 into 180 divided by voltage V1. What is the voltage V1? See here, the voltage V1 is 1500. So it is 1500. So current is equal to 410 ampere. Now this current is clear. Okay. So when current is clear, can we write the current in the section? Therefore, current I, we will write here so that figure in our side. Current IBC is equal to, therefore current in IBC is equal to, it is I1 minus I2. I1 is just we have calculated, it is 410 ampere. 410 minus current 300 is equal to 110 ampere. So IBC is equal to 110 ampere. So here it is equal to 110 ampere. Okay. Now last, C to D. What is C to D? ICD is equal to, it is I1 minus I2 minus I3. Since all load is given in unity power factor, so simply arithmetic sum is sufficient. I1 is equal to 410, I2 is equal to 110, I3 is equal to 300. So it is equal to 70 ampere. 70 ampere. Okay. So this is the 70 ampere. It is equal to 70 ampere. So in this way, we can calculate this current either in the two winding auto transformer, or here it is a three winding auto transformer. This is the end of auto transformer topic. Thank you.